only, and it has no specific direction in space. Examples? Yes. Mass. Okay. What? Or time, temperature. Bolo. Distance. Work. Yes. All these are scalar quantities, right? So scalar quantity is the quantity which has only magnitude and situation where magnitude alone is sufficient. वहां पे हम स्केलर क्वांटिटीज होती है जहां पे we do not require direction. ठीक है. So examples are length, volume, time, mass. These are the examples of scalar quantities. On the other hand, if a quantity has both magnitude and a specific direction, then we term that quantity as a vector quantity. Situation where magnitude and direction both are required, they will use vector quantities. Okay. And a vector quantity is the quantity that has both the magnitude and direction in space. They can be described by both the magnitude as well as direction. Examples of vector quantities are, okay, displacement, force, velocity, acceleration, torque. You don't know torque? क्या होता है torque? What is torque? It is the rotational analog of force. Okay, we'll discuss torque in rotational motion. So these are vector quantities. So let's revise what scalar and vector quantities are. In scalar quantities, we consider only magnitude, while in vector quantities, both the magnitude and directions are considered. Okay, please write this. So vectors have magnitude, vectors have direction. Vectors are those which can be added according to triangle law of vector addition. Because if we consider let's take one example of electric current. I think I've already discussed this example with you. Electric current has both the magnitude as well as direction, but electric current is a scalar quantity because we do not add current according to triangle law of vector addition. That's why current is considered as a scalar quantity, not a vector quantity. Though it has direction, but we consider current as a scalar quantity. ठीक है? तो वेक्टर्स के लिए सिर्फ मैग्नीट्यूड एंड डायरेक्शन नहीं है. We have third point, can be added according to triangle law of vector addition, and vector addition is commutative. Vector A plus vector B is vector B plus vector A. It is commutative. Okay, you can write this. Vector is represented by an arrow. Okay, so displacement is a vector quantity, so we can write displacement as this. Vector S, and length of the arrow represents the magnitude. जितना लंबा एरो बनाओगे उतना ही ज्यादा उसका मैग्नीट्यूड होगा. ठीक है. So magnitude of vector AB. How do we write magnitude? When we write magnitude, then we do not put the arrow sign. We simply write AB. It is clear. Or we can put this vector in modulus. If we are putting this vector in modulus, it is clear that we are considering only the magnitude. We are not considering the direction of that vector. Okay, it is understood. Or we can simply write AB. So there are two ways of writing magnitude of a vector. ठीक है. Mod vector. हाँ, जब modulus में होगा, then you have to put the arrow. But if you are not writing the term in modulus, then you don't need to put the arrow. It is clear that we are considering only the magnitude. We are not considering the direction. Clear? So next we have types of vectors. So we have different types of vectors. Polar vectors have a starting point and a point of application. On the other hand, axial vectors have rotational effect and they act along the axis of rotation. Examples of polar vectors are displacement, force. These are the examples. On the other hand, examples of axial vectors are torque and angular momentum. Angular momentum and torque produce rotational effect. We will talk about this when we'll study, when we'll do rotational motion. In rotational motion, we'll study polar vectors and axial vectors. See, let's understand now some special type of vectors. So we have equal vectors. So when two vectors are said to be equal. See, in vectors, we have both the magnitude as well as direction. We consider magnitude and direction. So if we have two vectors and they have the same magnitude and they are pointing in the same direction, then they are said to be equal. So if we have two different vectors, AB and CD here, this is represented by vector P and CD is represented by vector Q. So you can see that lengths are equal. this length of the arrow represents the magnitude of the vector. So their lengths are equal means their magnitudes are equal. They have the same magnitude and they're pointing in the same direction. Then they're said to be equal vectors. So vector P is equal to vector Q, or we can write vector AB is equal to vector C. Okay. So, this is यहाँ पर equal vectors हो गया. Two or more vectors having the same magnitude and the same direction, irrespective of their positions in space, are called equal vectors. You don't need to write the complete definitions. You'll get the handouts. Don't worry. You simply write the keywords. Okay, no need to write the statements. Okay, write keywords only. You'll get the handouts. Next, we have opposite or negative vector or anti-parallel vector. Anti-parallel vector means if one vector is pointing in one direction, other vector will point in the opposite direction. Parallel, if they are parallel vectors are if they are pointing in the same direction and same direction में भी है और एक ही साइड जा रहा है और equal magnitude जो equal vectors में लिया था. But if they are anti-parallel vectors means they are pointing in different direction. Opposite or negative. Opposite, if one is pointing in this direction, another vector will point in opposite direction. Or negative of a vector. Negative of a vector means because direction is opposite and therefore we put a negative sign there. Okay. So this is one vector, vector AB, and we have another vector, vector CD. They both are pointing in different directions. So vector AB and vector CD, they both are pointing in different directions. You can see they have equal magnitude. They are of equal length, but they are pointing in different directions. Okay, so this is vector P. This is represented by vector Q. So we'll write vector AB is equal to minus CD vector. Or we can write vector P is equal to minus vector Q. Okay. So a negative vector of a given vector is a vector of the same magnitude but different opposite directions. Any two vectors of same type which are equal in magnitude but opposite in direction are called opposite or negative vectors. Unit vectors, a vector having unit magnitude in a given direction is called a unit vector. Consider a vector A. A unit vector is given vector divided by magnitude of that vector. It is represented by A cap. We put a cap over the symbol and we can find unit vector using this formula. ये थोड़ा कम समझ आया होगा आपको तो आगे होगा. यूनिट वेक्टर क्या होता है इसको अंडरस्टैंड कैसे करें. लेट्स कंसिडर अ सिचुएशन. सपोज वी हैव अ वेक्टर ए. ठीक है, वी हैव अ वेक्टर ए. ठीक है, और इसको अगर हम इसका मैग्नीट्यूड लेते हैं, लेट्स से इट इज अलोंग एक्स एक्सिस. So because this vector is along x-axis, so we can write 5 I cap. For this, I cap represents the unit vector along x-axis. Okay. So this vector is 5 I cap. I cap represent the unit vector along. So this x-axis and this 5 is the magnitude of the vector. This 5 is the magnitude of the vector. Unit vectors are those where we have unit magnitude. Unit magnitude means where magnitude is 1. And direction is that of given vector. Suppose if I consider if I divide this is suppose it's a line segment and I'm going to divide this line segment into 5 equal parts. 1, 2, 3, 4, and 5. So one part is so this length of this is 5. Okay. So first part is 1 unit. Na? Its value is 1 unit. So for this small part, we can write 1 because we have divided this into 5 and the magnitude is 5 also. So this first part is 1. So this is the unit vector. If I draw another vector over this vector only, we can draw. Let's draw here. If I draw another vector of same magnitude, 1 unit, and pointing in the same direction, then it is called unit vector of given vector. And we denote this vector by vector A cap. Okay. And this is the formula of finding unit vector. How do we find unit vector? We just write a cap and this is equal to vector a, whatever जो भी value है हमारे पास, divided by magnitude of the vector, magnitude of that vector. So what is vector a in this case? It is 5 I cap. 5 I cap, and magnitude of a is, what is the magnitude of vector a? Vector a is 5. If I say that vector a is 5 I cap, then what is the magnitude of vector a? It's 5. So write 5. So unit vector is I cap. So I cap is the unit vector along this axis. So if a vector is of 0 magnitude, it has no magnitude, it is 0. So what direction we can expect from a vector which has no magnitude, which has 0 magnitude? It can move in arbitrary direction. Yes. We cannot specify a direction for a 0 vector because it is null vector. It is 0. इसमें कुछ है ही नहीं ना. So it has arbitrary direction. So a vector having 0 magnitude with no specific direction is called a 0 vector or null vector. जिसकी कोई specific direction नहीं है. We consider direction of this vector as arbitrary. Okay. So it is represented by 0 vector. 0 and vector. So what is the magnitude? Magnitude is 0 and direction is arbitrary. For example, the velocity of a particle at rest. Particle is not moving, its velocity is 0, so it's a 0 vector. The position vector of a particle at the origin. If the particle is at origin, then we can write the position vector as 0 vector. Because at origin we have the coordinates 0, 0 in xy plane. Yes? Okay. Next. Now we have a list of vectors here. So out of these vectors, we have already discussed unit vectors we have covered, equal vectors we have covered, negative vectors we have covered, co-initial vectors we haven't done. Co-initial, co-linear, co-planar. So we have 3 co-vectors here. Okay. Co-initial means which have common initial point, which have same initial point. Same line, same plane, same initial point. Okay. The word co जहां पे भी आएगा उसका मतलब क्या होता है? Same. So co-initial vectors are those which have the same starting point, which have the same initial point. So let's draw 2 vectors. So look at these 2 vectors now. Let this vector be vector A. And this vector be vector B. This is vector A and this is vector B. You can see the starting point is coinciding. They have the same initial point. This is the initial point of a vector. And this is the initial point and this represents the magnitude. Length of the vector represents the magnitude. And this, see, length of the arrow represents the magnitude and this arrow represents the direction of the vector. And this from where it starts is the initial point or starting point of the vector. They have the same, both the vectors have the same initial point, so they are called as co-initial vectors. Coplanar vectors, which are on the same plane. So vectors which are on the same plane are coplanar. Okay, so let's draw 2, 3 vectors. We have this vector, this vector, this vector. All these 3 vectors are in the xy plane. If we assume that they are all in the xy plane, then they are called coplanar vectors. Okay. Clear? Any doubt? Next is collinear vectors. What are collinear vectors? Collinear means same line. Parallel. अच्छा, पैरेलल ले सकते हैं, सेम लाइन में ले सकते हैं कोलिनियर को. यस. So these are collinear vectors. ठीक है. All these vectors are collinear vectors. Draw these vectors in your notebook. Localized vectors वो होते हैं जिसकी fixed initial point होता है जिसको हम locate कर सकते हैं, and non-localized vectors वो होते हैं which cannot be located, which have no fixed initial. ठीक है. Rectangular unit vectors. Consider a coordinate axis system. See, xy axis है ये. ठीक है. This is z axis, and this I cap we have discussed when we had done unit vectors, right? So I cap is the unit vector along x-axis. Similarly, we have unit vectors for y-axis and z-axis. This we had discussed already in that class. Sunday वाली class में किया था. Along y-axis, which vector do we consider as unit vector? J cap, and along z-axis, it is k cap. So I cap represents the unit vector along x-axis, and j cap represents the unit vector along y-axis. K cap represents the unit vector along z-axis. So these are the unit vectors. ठीक है, ये हमने ऐसे कंसिडर किया है कि ये रेक्टेंगुलर यूनिट वेक्टर्स हैं. ये x, y और z एक्सिस के अलोंग होते हैं. Along x axis we have I cap, along y axis we have j cap, along z axis we have k cap. Okay. So rectangular unit vectors are the unit vectors along the positive direction of the axis of the coordinate system. Positive directions, we are considering only positive x-axis, positive y-axis, and positive z-axis here. And position vectors. How do we locate the position of an object? In a coordinate axis, we can locate the position of an object if abscissa and ordinate. If the coordinates are given, then we can easily locate, right? So a vector which represents the position of a point in magnitude and direction with respect to coordinate system is called position vector. So let's consider a point P in space having position 2, 3. So we can draw the coordinate axis. We can locate this point 2, 3. है ना? So position vector of point P with respect to the coordinate axis is this vector OP. What are the coordinates of origin? 0, 0. X is 0, Y is 0 at origin. Both X and Y are 0. So 0, 0 are the coordinates of origin, and this coordinates of this point P is given, it's 2, 3. है ना? So how do we write the position vector? So let vector P be the vector. So vector P is vector OP. So we can write vector P as 2i cap plus 3j cap. ये मैं अब समझाऊंगी इसको कैसे करना, don't worry. ठीक है? And vector O is 0i cap plus 0j cap. So vector OP can be written as vector P minus vector O. Put the values and you will get the position vector of vector OP. अभी आपने ये क्लास लिया था जब हमने 3 hours की क्लास किया था? You were here ना? देखो, see, इसमें क्या है? We have value of x as 2. Okay, value of x is 2 and value of y is 3. Right? So x is 2 and y is 3. Along x-axis, unit vector is represented by I cap. Along y-axis, unit vector is represented by j cap. Okay? So first we will write. If we want to write the write for vector P, then how will we write? See, vector, this can be written as 2 is the magnitude along x-axis. Okay, we'll write 2 first, and direction is I cap. This is the unit vector. This is how we write vectors. First we write magnitude and then we write direction. And a vector consists of both the magnitude as well as direction. So magnitude is 2 and direction is I cap along x-axis. Similarly, we'll write for y-axis. Magnitude is 3 and direction is indicated by the unit vector representing that axis. That's j cap. So magnitude plus direction. Okay. Similarly, because we know the coordinates of origin, it's 0, 0. Both x and y are 0. So we'll write 0i cap plus 0j cap. Okay. And how do we get the displacement? How do we get the position vector? We'll simply subtract these two to get the position vector OP. So vector OP is represented by this. Clear? Okay. Now, if I want to write magnitude of this vector OP. How do we write magnitude of a vector? Vector OP is given. It is 2i cap plus 3j cap. Now, how do we write magnitude of OP? The magnitude of OP can be represented as this, or we can simply write OP for this. कैसे find करते हैं? We take square root, write the magnitude which is along x-axis. It is 2 square, and then 3 square. What will you get? 4 plus 9. Square root of 4 plus 9 is 13. Square root of 13. Because we do not know the unit, so we'll simply write unit. Okay. Now, if I want to write unit vector along vector OP, unit vector along vector OP, how will we write unit vector along it? So we can write vector OP because we are writing unit vector this time. So we'll put a cap over this. We'll not write this vector sign. This time we'll mark this, will not mark this arrow. We'll write this, mark this cap. This cap indicates that we are finding the unit vector of vector OP. And what is the, how do we find? First we write the vector and then we write the magnitude of vector OP. We can enclose this in box, modulus, or we can simply write OP. Okay. Now, first write vector OP. Vector OP is 2i cap plus 3j cap, and magnitude of vector OP is root 13. Okay. Then we can segregate this. We can write 2 by root 13 I cap plus 3 by root 13 j cap. It looks nice when we write like that. अच्छा लगता है ना ऐसे? साथ में नहीं लिखना, अलग अलग लिखना है. x कंपोनेंट का अलग, y का अलग. ठीक है? आ गया? Now you know how do we find unit vector? How do we find modulus of magnitude of a vector? If a vector is given, if coordinates are given, then how do we write? If coordinates are given, then how do we write this in vector form? है ना? Vector form में कैसे लिख सकते हैं? Then इसका magnitude कैसे find करना है और इसका unit vector कैसे find करना है? Now you. First, yes, the unit vector of vector A is, you have 4 different options. Give me the answer. Now we have Z component also. First, हमें हाँ नहीं मिलानी है. Have you solved this? Have you solved? Pen किसी ने भी नहीं चलाया? Yes, answer is first. How will you solve this? Vector A is given. We'll find modulus of vector A. है ना? 1 square plus 2 square plus 3 square under the root. And then we will divide them. Good. Next question. The magnitude of vector P is A. Yes. Answer is A. Next question. The magnitude of vector A is how do we find magnitude? Any doubt? Man भी आ रहा है? Easy है ना?
Yes, ma'am.